I do have a very long introductory remarks, and so it was way too long. He has too many accolades and too many awards, but I will pare this down so you can just get a gist of the kind of man he is. Professor Loeb received his PhD in plasma physics at the age of 24 from the Hebrew University of Jerusalem, and was subsequently a long-term member at the Institute for Advanced Study in Princeton, where he started to work in theoretical astrophysics. In 1993, he moved to Harvard University, where he is the Frank B. Baird Jr. Professor of Science at Harvard University. He had been the longest serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and the director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Professor Loeb is a fellow at the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astrophysics. In June 2020, Professor Loeb was sworn in as a member of the President's Council of Advisors on Science and Technology at the White House. And the Time magazine had selected Professor Loeb as one of the 25 most influential people in space. So please welcome Professor Loeb.
Thank you so much, John, for the kind words. I should clarify that all these titles that I accumulated over the years are not as significant to me as my childhood curiosity. And I regard doing science as maintaining your childhood curiosity. It's a great privilege, especially if you get tenure. You can pursue your questions and wonder about the world. And that's pretty much what I enjoy doing right now. And the titles do not mean much to me. I will speak primarily on the book shown here in the middle of this slide, Extraterrestrial. If I had to summarize it with one sentence, I would say, when you are not ready to find exceptional things, you will never discover them. And what you see on the right-hand side of this slide is another book that I published over the past 7 months. And it's called Life in the Cosmos. It's a textbook of more than 1,000 pages that lays the foundation for the scientific search for life in the universe, both the microbial primitive life, as well as technological intelligent life. What you see on the left side of this slide is a photograph that was taken by Herlinde Quilbel, a German photographer, and was shown in an exhibit at the Berlin Brandenburg Academy of Science and Humanities on October 2020. And she came to my office about a couple of years ago and asked me to write on the palm of my hand the question that I regard as most significant in science. And I wrote, "Are we alone?" Just wanted to advertise two events that are upcoming. First, on Wednesday this week, there will be a conversation at the National Book Festival in the Library of Congress. You can see the details here at 7 p.m. And the second is actually a book signing event that will take place on October 18th at the Coolidge Corner Theater in Brookline, that will be followed by the film Close Encounters of the Third Kind. And about a week ago, I received this email. It was during the high holidays of the Jewish community, and a rabbi from a congregation in Ann Arbor, Michigan, wrote to me an email saying that he dedicated a sermon to my book, Extraterrestrial, and he posted the sermon online. And that had a profound humbling effect on me, because I realized at that point that the discussion on extraterrestrials has very deep connections to religious feelings and the existential questions that we have. And I actually published an article about it over the past week. A colleague of mine said after seeing this, next time we meet for dinner, my wife and I will ask you to give a sermon. And my reply was that I would never lead a congregation whose members agree with me. It's unnecessary. Now, again, a week ago, there was a call by the Congress to establish a permanent office that addresses unidentified aerial phenomena, which makes it quite interesting. The government, which is a rather conservative organization, is discussing UAP, unidentified aerial phenomena, seriously. Now, over the several decades that I studied astronomy and practiced astronomy, I developed a strong sense of modesty, given the scale of the universe. We now know that about half of the sun-like stars host a planet the size of the Earth, roughly at the same separation. So not only that we are not at the center of the universe, like the ancient Greek philosopher Aristotle argued, and people believed him for 1,000 years because it flattered their ego. Not only that the Earth moves around the sun, we are not at the center of anything, but also what we find in our backyard is not special or unique. We are born into this world like actors put on a stage, and we are not at the center of the stage. The size of the universe is 10 to the power 26 times bigger than the size of our body. And the play has been going on for 13.8 billion years. We just came at the end. The play is clearly not about us. There are more habitable Earth-like planets in the observable volume of the universe than there are grains of sand on all beaches on Earth. Just think about it. So that brings the sense of cosmic modesty. But when you see a painting like the one depicted in the middle of this slide of an emperor being very proud of himself after conquering a piece of land here on Earth, you get the sense that this is not very impressive because it's just like an ant hugging a single grain of sand on the landscape of a huge beach. Nothing to be proud of. But I can understand where it's coming from. When my daughters, I have two daughters, and you see them here, when they were very young, they tended to think that they're at the center of the universe, that in fact, they are the smartest in the world. And when we took them to the kindergarten, they got a different perspective. They saw kids that might be smarter than they are. And so our civilization will mature only after we meet others. And the reason that we might not be the smartest or the most advanced is that most stars formed billions of years before the sun. We know that. We observe the universe, we see the star formation history of the universe, and the sun formed relatively late. So there are many sun-like stars that formed billions of years before the sun. And a large fraction of them had an Earth-sized planet roughly at the same separation from that star. So the circumstances that we find here on Earth were replicated long before we came to exist. And we are right now developing artificial intelligence that drives cars and in the future will make medical decisions. So just imagine an AI system being sent to space. It's sort of like you can educate it, you can train it, just like you educate your kids early in life, and then you send them to the world. They become autonomous. They don't need guidance from you. And so the same may be true in the future when we send AI systems into space. As of now, we sent relatively dumb equipment into space. I mean, the most advanced equipment is the Perseverance rover that landed on Mars, but it's still being instructed by by NASA, by JPL engineers. It's not autonomous. It's not like an astronaut. But in the future, AI systems could replace astronauts because humans were selected by Darwinian evolution to stay here on Earth. We are not really suited for long travel through space, and we better send our technological kids, AI systems that could survive for billions of years throughout space. They could be our monuments. They could represent us in the long term, because eventually the sun will boil off everything that we have right now here on Earth. And so in 1 billion years, a civilization like ours could potentially populate all habitable planets in the Milky Way galaxy with AI systems that are equipped with 3D printing capabilities so that they can reproduce themselves and make copies. And so the question is, do we live in such a reality where an advanced technological civilization predated us by 1 billion years and there is equipment around us floating in space? The only way to find the answer to this question is to search through telescopes. There is no point in arguing about it philosophically. And the reason I say that is because 4 centuries ago, Galileo Galilei looked through his telescope and argued that it's likely that the Earth moves around the sun. And the philosophers at the time said, no, we know that the Earth is at the center of the universe and that the sun moves around the Earth. And they put Galileo in house arrest. Today, he would have been canceled on social media. But that didn't change the fact that the Earth moved around the sun. So we don't want to repeat the mistake of those philosophers at the time. And you would be surprised that a few months ago, there was an article published in Nature Astronomy magazine by a philosopher arguing that an unusual object that passed near the Earth called Oumuamua, that I will discuss in a few minutes, must have been natural in origin. And when I read that paper, I thought to myself, haven't we learned something over the past 4 centuries? Apparently not. So I decided to establish the Galileo Project. And in July, there were a number of very wealthy individuals, multi-billionaires, that visited the porch of my home, asked me questions about my book, Extraterrestrial, and decided to provide me with $2 million for my research. And that established sufficient funds for me to inaugurate the Galileo Project. And one way to look at it is that we plan to look for the answers through new telescopes, just like Galileo did, because extraordinary conservatism leads to extraordinary ignorance. And so the Galileo Project aims to follow 2 tracks. One is to look for unidentified aerial phenomena, objects near Earth that might not look like a bird, a drone, an airplane, human-made technologies, something unusual. And we plan to do that using telescopes. Just to give you an example, a meter-sized telescope can obtain a megapixel image of a human-sized object at a distance of 1 mile. And I found such a telescope online a month ago, and it says add to the bag. And if you click on that, it costs only $500,000. Apparently, there are people willing to pay $500,000 and add it to their bag. We don't have that much money to add many such telescopes to the bag of the Galileo Project, so we will use slightly smaller telescopes. The idea would be to obtain high-resolution images of UAP in order to discover their nature. So if we can get a megapixel image of an object the size of a person, we could see the head of a pin on such an object and distinguish between a label saying made in China, made in Russia, in which case we'll be happy to transfer the information straight to people in Washington, DC, and a label saying made on exoplanet X. That would be interesting. I'm not a zoologist, so if we see a bird and get a very high resolution image of a bird, again, we can design software that will transfer it directly to zoologists. A drone or an airplane would be as boring as a bird, as far as I'm concerned. We will just look for something unusual. It's a fishing expedition, so we might see a lot of sardines. These are objects that are not of great interest. They have mundane explanations. And if we don't see anything else, so be it. But if we find just one object that may be from an extraterrestrial technological origin, that could have a profound impact on the future of humanity. So the search is worthwhile. And it needs to be done by scientists. The second component of this search would be to look for unusual objects that came into the solar system from outside. And the first among them was called Oumuamua, and I'll discuss it in a few minutes. It didn't look like a comet or an asteroid, all these rocks that we have seen before in the solar system. And the question is, what was it? We want to find more objects of the same and take a high resolution photograph of them. And obviously, we're open to any additional funds that anyone would like to contribute to this scientific project. And there is a link down there for interested people. So as I mentioned, the Office of the Director of National Intelligence delivered a report to Congress on the 25th of June this year, in which there were 143 unidentified aerial phenomena. And some of them were declared as real objects because they were detected in multiple ways and in different types of equipment, infrared, optical, different people saw them. And yet their nature was not understood. It was unclear whether they're human-made or something else. And given the fact that the military personnel could not infer their nature, and serious people talk about these objects as being real, I think it's time for this subject to move away from the talking points of politicians into the realm of science. Because in the past, scientists ridiculed this subject and the public was left to speculate. That's not a healthy situation. And so the Galileo Project aims to get a rich data set from instrumentation that we have full control over. It will not be a camera on a jittery cockpit of a fighter jet. It will be a telescope system that we fully understand, and the quality of the data would be state of the art. And we will try to figure out using the scientific method as to what these objects are. And this is really the first time that a group of scientists came together. And I was glad not only to get the funding for the research, but also within a few weeks to assemble a team of 25 exceptional scientists, mostly astronomers, that you can see in these images, including the principal investigators on NASA's New Horizons mission. And we also have a scientific advisory board, including the person that invented Mathematica, Stephen Wolfram. And we have a philanthropic advisory board and a public outreach affiliates. And finally, we have a lot of research affiliates that I got thousands of emails after the project was announced, a month following the Pentagon report. A lot of people offered their expertise and contributions to make this project a reality. So there is a lot of public support for the project. Of course, most of the scientific community is still opposed to studying this subject. Now, the big picture is that the future of humanity is at stake, because currently all our eggs are in one basket here on Earth. The only remains of a human that made it out of Earth far away are the part of the ashes from Clyde Tombaugh that discovered Pluto. They were put on the New Horizons mission to Pluto. And I must say that it doesn't make much scientific sense what was done, because what are ashes? Ashes are burned up DNA. So you take the DNA of a person that has some information content, and then you burn it up. You lose all that information in memory of that person. It would make much more sense to put on the New Horizons spacecraft the genetic information about Clyde Tombaugh in electronic form. I just cannot understand why NASA would put ashes on a spacecraft, because if another civilization finds those ashes, they would say, what a meaningless symbol of a person. The ashes are no different from the ashes of a cigarette that you put in a tray. I mean, there is no information content there. To celebrate a person, you need to put his or her DNA on the spacecraft, or maybe a stem cell. So Earth is currently our home, but only for a limited time. There are threats that are related to self-inflicted wounds, such as climate change, wars, pandemics, or technological or political catastrophes that may take place. And of course, there are external threats, including asteroid impacts. The dinosaurs 66 million years ago were very proud of themselves. They dominated the environment around them, but then a giant rock the size of Manhattan Island hit the ground and tarnished their ego trip. And we should be worried about a similar thing happening to us, of course. Eventually, the sun will boil off all the oceans on Earth. So when I go to University Hall, the place where Harvard is being managed, I often see portraits or sculptures of former deans and presidents, and they try to preserve their physical appearance in some form, in the form of a painting. However, all of this will go away when the sun will boil off everything here on Earth. The only way to maintain some memory of what used to be on Earth is to send spacecraft equipped with artificial intelligence and 3D printing, such that they could reproduce what we care about far away. And I call that Noah's spaceship, similar to the biblical story about Noah's Ark, where he tried to preserve animals by building an ark to save them from the great flood. So a few words about my journey from childhood to space exploration. I was born in 1962, 59 years ago, in Israel, in a small village. You can see a photograph of me at age 6 at the top left. And I used to collect eggs every afternoon. I was mostly interested in philosophy, so I used to drive a tractor. You can see me on a tractor with my sisters in the middle top photo. I used to drive a tractor to the hills of the village and read philosophy books there, because they addressed the most fundamental questions that we have, unfortunately, without a good answer. And one thing led to another. I served in the military and then ended up developing a project that was funded by the US. And eventually I got to Harvard, was tenured there, and became chair of the astronomy department. In May 2015, a black limousine parked in front of the Center for Astrophysics at Harvard. And out of it came an entrepreneur from Silicon Valley named Yuri Milner. You can see him on the bottom left picture. And he came to my office, sat on the sofa in front of me, and asked me, "Are you willing to lead a project that will visit the nearest star. And I knew that the nearest star is 4 light years away. So it takes light 4 years to traverse that distance. And if you want to get there within our lifetime, you need a spacecraft that moves at 1/5 of the speed of light, so that it will take about 20 years. And that is 1,000 times faster than the chemical rockets that we have used since Sputnik all the way to New Horizon. So a factor of 1,000 is a big factor. It's the difference between the first car, commercial car, the T car that Henry Ford developed, and Sputnik. So that's a big gap. And I had to think about which technology would enable us to launch a spacecraft at 1/5 of the speed of light. It took me 6 months, and then I recommended a method that I'll describe in a few minutes. And we announced this project called Starshot, as you can see in the middle bottom photo, in the company of Stephen Hawking and Freeman Dyson, New York City, in April 2016. So here is an artist's illustration of the solar system. You see the sun on the left, and the nearest star, Proxima Centauri, which is actually a member of a 3-star system, the Alpha Centauri system. You can see it on the right. And the solar system goes halfway to the nearest star. The outermost part of the solar system is called the Oort cloud. It's made of the building blocks that made the planet. These are the bricks that were used in the construction project of the planets in the solar system. And they are just rocks covered with ice that fill up a huge volume halfway to the nearest star. And it turns out the nearest star, Proxima Centauri, is a dwarf star. Most of the stars are much smaller than the sun. It's 12% the mass of the sun and half the surface temperature of the sun. And so it emits mostly infrared light. But it so happened that even though the star is very faint, there is a planet roughly the size of the Earth, which is 20 times closer to the star than the Earth is from the sun, so that the temperature on its surface is similar to that on the surface of Earth. So it's considered to be a habitable planet. But it's so close to the star that it's tidally locked. Just like the moon shows us the same face at all times, this planet shows the star the same face at all times. There is a permanent day side and a permanent night side. And my daughters say that if we ever go there, they want to have a house in the strip that separates the night side from the day side, where they can sit on the porch and see the sunset forever. Just imagine sitting on the porch and seeing the sunset forever. The sun never sets on that strip. And I asked students in my freshman seminar class at Harvard last semester whether they know of any animal that has infrared vision that may live on the day side of this planet. And the brightest student found an image from the internet that of such an animal. And it's a shrimp that has eyes that look just like ping pong balls connected with cords to the head of the shrimp. And when she looked at the image, she said, "It looks like an alien to me." So how do we get there? The method is pushing a sail, the type of a sail that you find on a sailboat, pushing it with light. Because if you push something with light, it could reach the speed of light. That's what we want, 1/5 of the speed of light at the very least. And you need a very powerful laser and a thin film of material to which one can attach the guts of a cell phone, basically a camera, navigation device, communication device. This is called the Starshot initiative. And you can see here an illustration of the project. A lot of low power lasers combine their beams into a very powerful laser beam that shines through the atmosphere and reaches a sail that is released by a mother spaceship above the atmosphere. And if the sail weighs roughly a gram and the laser beam is about 100 gigawatt, then within a few minutes, the sail will reach a fifth of the speed of light across a distance that is 5 times the distance to the moon. So the launch takes a few minutes to a fifth of the speed of light. And then the journey to Proxima Centauri takes 20 years. And that's why I say that humans are not really designed for interstellar travel. What you see in science fiction movies does not make much sense. So when this equipment would reach Proxima Centauri, it could potentially take a photograph of the habitable planet next to it so that we can tell if there is life on it and send that signal back to Earth. And of course, it will take 4 years for that signal of light to reach us. So altogether 24 years, that's a long time. Even for the nearest star, we cannot get things done faster than that. Now, in principle, one can push a light sail, not just with a laser. You can imagine parking light sails next to a star that is about to explode, a massive star. And then when the star explodes, it generates a flash of light. So the situation is similar to those surfers that wait on the beaches of Hawaii for a giant wave to carry them. Here, we're talking about a wave of light from an exploding star. Another way to think of it is dandelion seeds that you can see on the right-hand side that are carried by the wind. And such a sail near an exploding star could easily reach the speed of light. So maybe other civilizations park sails close to the location of a star that is about to explode. Now, we are probably not the sharpest cookie in the jar of the Milky Way. We're not the smartest. And the reason I say that is because I check the news every day. And the way I define an intelligent culture is a culture that follows the guiding principles of science, meaning sharing evidence-based knowledge. And one thing you see in human history is that we don't share things very often. In fact, even during the COVID-19 pandemic, when it started in Wuhan, China, there wasn't much sharing of information, even though it could have saved a lot of lives. And the second part, which is not represented in policy making, is it's not evidence-based very often. And so we have some long way to go before we might be recognized by other civilizations as intelligent. And one example that I often give is the Second World War, where the Nazi regime triggered the deaths of 75 million people. That was 3% of the world population in 1940. Just think about it, it's 20 times more deaths than the number of deaths triggered by the COVID-19 pandemic so far. And that was just a group of people that decided to feel superior relative to other people. Clearly, human history does not demonstrate a lot of intelligence, because if there is an intelligent civilization out there that is far smarter than we are, all our differences will become laughable. Our genetic differences are really meaningless relative to a species that is far more advanced than we are. And if you look at recipe books and you open them at a random page, the chance that you will encounter the page that gives the recipe for the best cake possible is very small. So the chance that Earth baked the best possible cake is small. And without prejudice, let's be open-minded and search for evidence of others. They might be smarter than we are. And the first place to check is in our backyard. And the first object that was discovered from outside the solar system in our backyard is Oumuamua. Checking the solar system is just like checking your mailbox to see if there are any packages in it. Now, of course, a lot of scientists would say, oh, we don't have any mail. Let's not even waste energy or resources on trying to check our mailbox. But my point is, maybe there is a package that is important for the salvation of the human species. And if we don't check it in time, we will lose an important piece of information. It will be sort of like finding a love letter long after it was due. So this object that was discovered in October 2017 by the Pan-STARRS telescope in Hawaii was named Oumuamua because it means a scout in the Hawaiian language. You can see it circled in blue in the middle of this photo and stars moving relative to it in the background. And it was weird because we didn't expect to find it. And also it started in a very special frame of reference, the so-called local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And Oumuamua was at rest in that frame, just like a buoy sitting at rest on the surface of the ocean. And then the solar system, like a giant ship, bumped into it. And only 1 in 500 stars is so much at rest in the local standard of rest as Oumuamua was. So that's unusual. And why would it be in that state? Here you can see the kick that it received by interacting gravitationally with the sun. And as the object was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that the object has a very extreme shape. And when trying to fit the variation of light as the object was tumbling, the best shape was that of a disk at the 90% confidence level. It looked like a pancake, not like a cigar. And then the most unusual fact about it was that there was no gas or dust around it. So it was not a comet for sure. We didn't see any cometary tail. A comet is just a rock that is covered with ice. So when it gets close to the sun, it warms up and the ice evaporates. But there was no gas or dust around this object. And the Spitzer Space Telescope looked very deeply and didn't find any traces of carbon-based molecules. So clearly not a comet. Yet the object exhibited an excess push away from the sun. And without the rocket effect of evaporation, to get this push, it needed about 1/10 of the mass of this object had to evaporate, but we haven't seen anything evaporating from it. And the only way I could explain its push away from the sun is through the reflection of sunlight. And the force acting on it behaved just the way you expect from reflection of sunlight. It declined inversely with distance squared in a smooth fashion. But in order for sunlight to be effective, this object had to be very thin. And nature doesn't produce very thin objects. So I suggested maybe it's artificial in origin. Maybe it's like a trash bag that is swept out and it's space trash, or maybe it serves some other purpose. And the fundamental question is whether Oumuamua was natural, a rock of some unusual type, or an artificial object. And after I finished writing my book in September 2020, there was another object discovered by the same telescope in Hawaii. It was given the name 2020 SO. And because the discoverers thought that it's an asteroid, a rock, and then it exhibited an excess push away from the sun by reflecting sunlight without a cometary tail. So it shared the qualities of Oumuamua. But then the astronomers realized that if they extrapolate the trajectory back in time, this object actually came from the Earth. It was launched in 1966. It's actually a rocket booster of a lunar lander. And we know why sunlight pushed it, because it had very thin walls. So it had a large area for its mass. It's clear that this object is artificial because we produced it. The question is, who produced Oumuamua? And there are a number of anomalies, unusual facts about Oumuamua. First, we didn't expect to find any rock. I did a calculation a decade earlier, and based on what we know in the solar system, there is just the abundance of rocks coming from other stars is too small for us to find any. And then it originated from this local standard of rest. Its brightness changed by a factor of 10 from reflection of sunlight as it was tumbling. That's a very extreme factor. And the best fit to the light curve was that of a pancake-shaped object, flat. And most importantly, it deviated from an orbit shaped just by the force of gravity. There was an additional force acting on it, and I suggested it's the reflection of sunlight. Now, since this proposal, there were a number of astronomers that tried, nevertheless, to explain it as a natural object, and all of them had to invoke something that we've never seen before. For example, a dust bunny, a collection of dust particles in a cloud that is 100 times less dense than air. The problem with that idea, even though you can easily push such a fluffy cloud by reflection of sunlight, the problem is that when it gets close to the sun, it will get heated up by hundreds of degrees and will not maintain its integrity. Then there was a suggestion, maybe it's an iceberg, a chunk of frozen hydrogen, such that when hydrogen evaporates, we don't see it, it's transparent. So there is a cometary tail, but it's made of hydrogen. And the problem with this scenario, first of all, we've never seen a hydrogen iceberg in astronomy. We don't know if they are produced anywhere. But second, such an object would get evaporated very quickly. It wouldn't survive the journey through interstellar space. And then there was a suggestion, maybe it's a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a planet like Pluto. And the problem with that is there is just not enough nitrogen on the surface of planets like Pluto, everywhere in the Milky Way galaxy, just not enough. And I will not get into all the details. But I will just say that a few weeks ago, there was this paper published where in the abstract of the paper, in the middle sentence that I highlighted in gray here, the authors say that both the hydrogen and nitrogen models have serious difficulties. And these are the authors that proposed the hydrogen iceberg model. So I rest my case. And my suggestion is that when you walk on the beach, very often you see rocks that were naturally produced among the seashells, but every now and then you see a plastic bottle. And perhaps Oumuamua is a plastic bottle that indicates that it was produced by a civilization artificially. Now, of course, if you imagine a caveman finding a cell phone, the caveman would argue that the cell phone is just a shiny rock. It's a rock of a completely new type that the caveman never saw before. It's a never seen before rock, just like a hydrogen iceberg or a nitrogen iceberg in the case of Oumuamua. But this is just the beginning of a learning experience, because the caveman can press a button and record his voice, and the caveman can press a second button and record his image. And then he would realize that it's not a rock, it's something else. And the same is true for us. We could potentially land on such an object as Oumuamua and press some buttons. And we could potentially just pass by and take a close-up photograph that will tell us that it's not a nitrogen or hydrogen iceberg, but it's technological equipment. And I should mention that in 2019, there was a second object from interstellar space that was discovered. It was given the name Borisov because it was discovered by a Russian amateur astronomer, and it looked just like a comet. So people ask me, well, this one looks natural. Doesn't it say that Oumuamua was natural? And my reply was, when you find a plastic bottle on the beach, and after that you find a rock, it doesn't make the plastic bottle a rock. And of course, a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write a book if we had a picture like this one that was taken by the OSIRIS-REx mission that not only took that picture, but also landed on the asteroid Bennu and will bring a sample from it to Earth in 2023. So we need to keep in mind that this play is not about us. We are not central actors here. We were just added at the end of cosmic history. And we could search for others, not just by looking for relics that they left behind, some equipment they sent into space, but also by searching for industrial pollution in the atmospheres of other planets. I wrote a paper about it in 2015. You can search for special reflectance from photovoltaic cells on the day side of a planet like Proxima b. You can search for beams of light that are used to propel light sails. You could search for artificial city lights on the night side of a planet like Proxima b. And we wrote a paper about that with an undergraduate student from Stanford, Elisa Tabor, a few months ago. So Enrico Fermi, about 70 years ago, went to lunch in Los Alamos and asked, where is everybody? If they exist out there, why don't we see them? And to me, that's very presumptuous because it assumes that we are interesting enough for them to come and have a party in our backyard. And why would they think that? I mean, the other thing is that most of them might be dead by now because, as we know, technology enables also the means for self-destruction. So they may have a short lifetime. We might have only a few centuries left, given the way we behave right now. And so what we should engage in is archaeology. In the past, we searched for signals, radio signals. That's just like trying to find a partner that will converse on the phone. But for that, the counterpart has to be active. It's possible that most of those civilizations that predated us are not around anymore. So the way to find out about them is by engaging in archaeology, this time in space. Most cultures that lived on Earth are not around anymore. The same may be true in space. So we can look for artifacts or other signatures, burnt up surfaces of planets that indicate that other technological civilizations are out there. And my hope is that finding relics of more intelligent civilizations would inspire us to do better, to deserve their attention, and to ignore the small differences between us and cooperate as equal members of the human species. Thank you.
Wow, that was a lot to think about. You're right. I mean, we might not be of any interest to anybody. That's very mind-blowing to me. Anyway, we do have a couple of questions, and so I'm going to read them. So if you have any questions for Professor Loeb, please put them in the chat function. Okay, there are many, this one was at the very beginning, there are many secret programs that the government does not share. I read the secret program by JFK, which sent people to an alien planet, Serpo. This was written by one of the people who was part of the program. I guess that doesn't really require an answer. I'm sorry, I didn't read these before. Are there any evidence at all according to 60 Minutes, there are things that cannot be explained away.
Right. So my take on this is that the data that was released is not scientifically convincing. We're talking about fuzzy images, and we have no idea of what the recording devices were doing at the time. As I said, a camera sitting on a jittery cockpit of a fighter jet is not really a scientific experiment. You want to have full control over the camera when it's taking the photos. And if you see the object moving around in a strange way, it may mean that the camera was moving around in the opposite way. And as a result, I'm not really interested in any classified information because that would limit my freedom as a scientist. And I would much rather look at the sky because most of the sky is not classified. And we can, astronomers do it all the time. Now, the difference between the Galileo Project and past observatories is that if a bird flies above a telescope that it exists right now, the astronomers will ignore it. We, on the other hand, will identify the bird and track it. And when we see that it's a bird, we will just forget about it. But in general, we will look for objects that are relatively close to us. I should say that at Harvard, when I announced the Galileo Project, the higher administration asked me, is this work related to your day job? They wanted me to justify it because otherwise they wouldn't allow me to use the funds through my activities at Harvard. And I thought about it for a few minutes, and then I told them, throughout my career as an astronomer, I looked at data that was assembled by telescopes and interpreted that. And we are doing exactly the same thing with the Galileo Project. There is no lower limit on the distance of the objects of interest in astronomy, as long as you're using telescopes. So, astronomers look at the sun, astronomers look at meteors, asteroids, comets, and therefore, this is part of astronomy. We are just looking at nearby objects in the case of UAP. And in the case of Oumuamua-like objects, they're not even nearby. They're just like asteroids or comets in terms of the distance. So it's definitely part of my day job. And they agreed.
Good. The question, do you have any doubt that some form of life exists in our solar system?
Other than the Earth, you mean? Yeah, probably it's primitive because we have no clue to anything that predated us that was intelligent, although I should not exclude that because, the recorded history here on Earth is only of the order of 6,000 years. And that's a small fraction of the age of the Earth. It's 1 part in a million or so. And so we don't know really whether an intelligent civilization with technologies that predated us by 1 billion years on Earth. We don't know that. But we have no evidence for that. And at the moment, we should assume that we are the first to emerge in the solar system as intelligent. Now, primitive microbial life very likely existed on Mars, I would say, and the Perseverance rover is looking for signatures of that. And of course, everyone would be happy if we find microbes somewhere in the solar system because we can still feel superior relative to these microbes. We are much more intelligent than they are. But imagine the Perseverance rover bumping into the wreckage of a spaceship that we didn't produce. That would be a shock to our ego. I mean, a lot of people will be offended by that. And
Right.
because it will turn out that we are not the smartest kid on the block. And of course, there are, aside from Mars, there are missions now planned to visit Venus, the other planet in our vicinity. And also, people suspect maybe under the ice in the moons Enceladus or Europa, there is an ocean where life may exist, and we see plumes of vapor, water vapor coming off these objects, and perhaps we could examine them to see if there are any traces of the life under the ice. So there is hope to search for primitive life, but in terms of intelligent life, I think the best approach is actually to look for equipment flying by which we have never searched for, or to look for signals which we have searched for 70 years, but we haven't found anything.
Right. I was just going to ask, when you talked about microbial life, what is it? What are they looking for when they say search for evidence of it? What kind of evidence would they see?
Well, it depends in which context, but on Mars, it's some fossilized signatures of life forms that may have
okay
there.
That's
But
fair.
in the case of really living organisms right now, Mars cannot have liquid water on its surface because it lost its atmosphere. But early Mars had an atmosphere and could have had life as we know it on Earth. It's even possible that rocks from Mars seeded life on Earth, that we are all Martians. It's possible. But and frankly, I don't think it matters whether we started on Mars and came here or not. But we will not find real life over there because there is no liquid water. I mean, it's hard to imagine how it would have been preserved for billions of years.
Mm-hmm. Another person asked, how come we can have a picture of a black hole and not any tangible proof of extraterrestrial life?
Well, because we invested more than $1 billion in the search for black holes. So just to give you an example, the LIGO experiment was funded at the level of $1.1 billion by the National Science Foundation. Oh. Before it was funded, we didn't have any evidence for gravitational waves that are produced when two black holes collide. And of course, after it reached the level of sensitivity needed, we did discover that, and the Nobel Prize was awarded a few years ago. Now, the problem with the search for technological life elsewhere is that a lot of scientists just ridicule the subject. They say, we need extraordinary evidence, yet at the same time, they're not providing the funds necessary to do the search. So it's a circular argument saying, you know, we need extraordinary evidence, but we don't, until then, we will not fund the search. It's sort of like saying we don't have any package in our mailbox, but in order to find the package, you really need to go to the mailbox and check it. And that means investing hundreds of millions of dollars in the search. Now, I should say that for 4 decades, we've been searching for most of the matter in the universe. We call it dark matter because we don't know what it is. There was a very popular type of particle that people imagined back in the 1980s when I started my career in astrophysics, and hundreds of millions of dollars were invested in searching for this type of particle, and it was not found. And at some point I asked an experimentalist, how much longer will you search? Because, you know, you may do it throughout your life and not find anything. And he said, as long as I'm funded. So my point is, okay, I have no problem with that, that this is part of the mainstream of astronomy, because it's an important question. What is most of the matter in the universe? But frankly, it will have very little impact on our daily lives, daily routines. Whereas if we were to find that Oumuamua was a technological relic, it would have a huge impact on the future of humanity, because it will give us a different perspective about our place in the universe. And my point is, we need to invest in that search as much as we invest, at least as much as we invest in the search for dark matter, before we can claim that we don't see any extraordinary evidence. And that's the culture that I'm trying to change. And I wrote a lot about it in my book, Extraterrestrial.
Well, Oumuamua, I hope probably messing that up, was it photographed as it passed through the solar system? Did those photographs reveal any clues as to the nature of this visitor to our solar system? Any of the photographs?
It was observed as a point source of light, because with the telescopes we have on Earth, we could not resolve it.
Right, but that's what you were sort of explaining there, but it was... So
it was roughly the size of a football field at a distance which is a fraction of the distance to the sun. And even with a 10-meter telescope, the biggest telescope we have right now, we can't resolve such a small object at such a distance. We need to fly by it and take a close-up photograph of the type that I mentioned. And we can do that with a future object like Oumuamua that we will identify ahead of time on its approach to us. If we discover it a year in advance before it gets to us, then we can send a spacecraft equipped with a camera that will intercept its trajectory and take a close-up photograph. And so my point is that it's not a philosophical question. We can answer the question of what's the nature of Oumuamua-like objects by taking a close-up photograph, and that's what we should aim to do.
It's also all about money at this point. You need that $500 million for that telescope that you were talking about?
Yeah, well, right now in the Galileo Project, we have $2 million, but what we need in order to have to cover enough of the sky and have a reasonable chance of finding things is 10 times more, so at the level of $20 million or so, which is not a lot of money when you deal with big scientific projects. As I mentioned, the search for dark matter was hundreds of millions of dollars. And
right.
I should say that aside from the culture that I described, which is very conservative and argues that we should not spend the money until we have the evidence, there is another component of the mainstream in theoretical physics, which is addressing ideas that do not have any experimental verification, such as extra dimensions, the multiverse, string theory. These are things you hear about that have no clue from an experimental point of view. And nevertheless, a lot of theoretical physicists that describe them as part of the mainstream because it allows them to do mathematical gymnastics to demonstrate that they are smart. And much of the academic activity is about showing that you are smart. And I find that as a betrayal of the promise of science, which is to try and figure out what nature is, to learn about the world. It's not about ourselves, and whether, it's not about getting more likes on Twitter. It's about finding the truth. And that was evident from the experience of Galileo.
Mm-hmm. Well, this sort of, in a way, leads into the final question. And it also touches on your philosophical training. If something makes contact with humanity, in your opinion, is this the end of religion and theology?
Not at all. For example, there was a cover story in the Orthodox magazine Ami in Brooklyn, New York, about my book. And a colleague of mine at Harvard said, it looks like the Orthodox are more open-minded towards your ideas than some of your colleagues. So I would say that I spoke with religious people, and many of them say that they are open to the possibility that we are not alone. I should say this is an important revelation, because if you go back several centuries, you find the history of Giordano Bruno, who basically said that other stars are like the sun, and they should have planets like the Earth, and there should be life on those planets. And he was burnt at the stake at the time because the church at the time argued that, if there is life and it sinned, it has to be saved by Christ, and you need a lot of copies of Christ to visit all these planets, and that makes no sense. And so he was burned for that. But nowadays, when I speak to religious people, they tell me that there is no conflict, and they would accommodate that. Therefore, there is the fundamental question that is metaphysics, beyond physics. Whatever we find in reality is physics. Mm-hmm. But beyond that, there is the question of who orchestrated all of that. And on that, science could not provide an answer. So I would say there is never an end to religion, because there is always the meta question of, you see a building and you can understand how the bricks were put together, but the question is, who was the architect?
Okay, and the questions are coming in. I'm sorry, I was reading a lot of this, but we'll end with this because it's getting to be the time. Do you think there could be life forms that do not obey Darwin's theory of survival of the fittest, which might conflict, which might avoid the conflicts that limit our species development?
Yeah, so I have a new version of Darwin's fittest, survival of the fittest, and my version is that there is a tension. If we are talking about a technological civilization like ours, there is a tension between two trends that relate to the technologies. One is that as technology evolves, we develop the means for our own destruction. As we well know, climate change and non-conventional wars and so forth. But at the same time, we also develop the means for launching monuments into space, into interstellar space that would represent us, sending AI systems that would think for themselves and carry the flame of human consciousness into the distant future, billions of years from now. So the question is, which trend would win? And, you know, if the self-destruction will win the day before we send out these monuments, then we will be buried under the rubbles here on Earth, and nothing will survive. All the eggs will be spoiled in this basket. But if we manage to send something out of space, these will be our technological kids, so to speak, then something will be left of us. And that's the best way to preserve longevity. It's not to transfer your DNA to your kids, because once again, everything on Earth will be burned up. It's to send something that evades a catastrophe here on Earth. And I think the question of whether humanity will be remembered billions of years from now depends on whether we manage to send something before we destroy ourselves.
That's pretty heavy. Well, thank you very much, Dr. Loeb. We got lots of compliments. People were very interested in this subject, and it's obviously been in the news with the UAP, unidentified aerial phenomena. So it's been in the news. People are interested, and you just gave it a lot more for us to think about, and I thank you. I thank everybody for coming. We hope to see you at the library. Go to our website, which is chappaqua library.org.